All right, guys. So we'll move on to exercise 5B now. So we'll practice with some questions. So they say in the finite region bounded by the curve y equal x square minus 4x and the x-axis is rotated through 360 degrees about the x-axis to form a solid of revolution. Find the coordinates of its center of mass. And they have given you a hint here. They have said in this, so in question number one, okay, they are saying use symmetry to find the coordinates of the center of mass of the solid. So basically, they're asking you to use symmetry rather than going for the integration. So how do you use the symmetry to find the center of mass rather than using the integration? Okay, so first thing is we have to see how this curve looks like. Okay, so what type of curve are we dealing with? They are saying the finite region bounded by the curve y equal x square minus 4x. So first you have to see what is the finite region bounded by x square minus 4x, because when you just look at it, we don't even see the limits. So the limits also you have to figure it out. So which means first thing to do is you have to kind of like draw the graph here to see the finite region. So y equal x square minus 4x. So it's a quadratic, a plus x square is a quadratic minimum graph, right, guys? So you can take a x out and you get x times x minus the 4. So when y is 0, or when you cut the x-axis, okay, so you get x minus 4 is 0, and you get here x is 0 or x is 4. All right, guys? So you can kind of like draw a quadratic minimum graph. The cutting points are at x equals 0 and x equals 4. Can you see, guys? So these are the two cutting points. So draw a graph that passes through these 2 points, a minimum graph. So these should be like really simple stuff, right? So these are stuff that you have done in P1. Okay, so now they are asking you to take the finite region bounded by the curve x square minus 4x and the x-axis. So now, guys, what's the finite region? What do they mean by the finite region? The finite region is this one, right? Guys, can you see between the x-axis and the curve? This is the finite region. Do you agree? Okay, so between the x-axis and the finite region, this is the, this is the part that you get between the x-axis and the curve. So the finite region that they're talking about is this one. So this is the finite region. Can you see? Because it's bounded between the x-axis and the curve. So actually, over here, you don't need the other parts of the curve. So actually, you can erase all of this. We don't need any of this. Okay, guys, you don't actually need any of this. You can erase. So this is the part we are interested in. They say they take this part and they are rotating it, 360 degree around the x-axis. So both sides of the curve are touching the x-axis. You know the rule when it comes to rotating 360 degrees, right? Around the x-axis, you reflect whatever the part of the curve on the x-axis, right? You reflect. So when you reflect, you get something like this. Can you see? And then it's not only the reflection, it forms a complete 3D object. So basically, there are no open ends to show the circle, but you can see inside everywhere you have these kinds of circular planes, right? Can you guys see what I'm talking about? So overall inside you have all these circular planes. So you get you get a full 3D object here. All right, guys. So they're asking you to find the center of mass without using any integration. Simply to use the symmetry. So what's the answer? So clearly through symmetry, the center of mass is gonna be at 2 comma 0. Okay, guys, the center of mass will be at 2 comma 0. So you don't need to use any integration here. You can directly just by looking at the symmetry of the shape, because minimum curve is symmetric, right? So this part of the curve, around around the turning point, it is definitely symmetric. So therefore, the minimum curve is symmetric. So the other part of the curve, when you reflect and rotate 360, you're going to get a completely symmetric object, and then the center of mass of that object has to be exactly in the middle of 0 and 4. Okay, guys, so that's going to be 2 comma 0. So that's very clear. Okay, so now let's move on to a question where we have to use calculus. Okay, so moving on to question number 5, they say find by integration the coordinates of the center of mass of the solid formed when the finite region bounded by the curve y equal 3x square, the line x equal 1 and the x-axis is rotated through 360-degree about the x-axis. Now, of course, in this question, you won't be able to use the symmetry of the graph. Why? So that it will be very clear when you draw the graph, right, guys? Because now, unlike the previous question where you had a line of symmetry in the original curve, if you take y equal 3x square, so these are like basic stuff, okay? So y equal x square is a quadratic minimum that passes through 0, 0. So 3x square is also a minimum that passes through 0, 0, right? So there won't be much of a change. So I'll draw only this part. Okay, so they are saying find by integration the coordinates of the center of mass of the solid formed when the finite region bounded by the curve y equal 3x square, the line x equal 1. So let's say the line x equal 1 is over here. This is the line x equal 1. Okay, so this is the x equal 0, the place where you make the turn. Okay, so you have to get the finite region between these 2 points, right? Because this is the place where you touch the x-axis. The other part of the curve, you don't need to consider that, right? So the finite region is what I need to consider over here. Okay, so this is the finite region. Okay, between these 2 points. Okay, so you need to understand that x equals 0 is one of the starting points. Okay, so very clearly you can see that this part of the curve, I mean, it doesn't involve any line of symmetry. So now you know if you take this part, you can erase the rest of it. Okay, you only need to consider this part. Okay, and when you take this part and when you rotate it, okay, 360-degree, you know the rule that you're supposed to entirely reflect. Now, this is y equal 3x square curve. So when you rotate, you don't need to draw. I'm just trying to explain to you the science behind the process. So over here, you reflect this entirely, right? You reflect this entirely, right? And then, you know, the open end forms a circle, right? The open end always has a circular face. So you get this kind of 3D object. And very clearly, this 3D object, you can see now, unlike the previous shape that we obtained, this is not a, even though you have x-axis as a line of symmetry, you don't have any y line of symmetry. Do you agree? Okay, in the previous shape that we considered, the x-axis was a symmetry. Also, I had a y line of symmetry exactly in the middle of 0 and 4. That was the case in the previous question. But over here in this question, you don't have such a line of symmetry. So in this case, you'll have to go for this formula. So we'll have to go for the formulas, right? So in here, it's a sort of revolution where we revolve around the x-axis. So we have to find x bar using the formula. So x bar equals integration y square x dx over integration y square dx. All right, guys. So let's do that. So you can get the numerator and denominator separately if you want, or you can directly carry out the integration at once. Okay, so y square times x dx, and your integration limits, guys. Remember, you're dealing with respect to x because it's dx. So your integration limits will be from 0 to 1. All right, guys. So then integration limits are from 0 to 1. So y is 3x square. Y is 3x square. So y square is 3x square times x. Okay, so then 3x square is 9x to the power 4 times x with respect to x. So 9x to the power 5 dx. Are you with me, guys? Okay, so I still didn't integrate. I just expanded the bracket. Y square is 3x square. And then it's time to integrate. So when you integrate, it's 9x to the power 6 over 6. And then integrate, input the limit. So it's going to be 9 into 1 to the power 6 over 6, right? So that's going to be 9 over 6. That's 3 over 2, guys. Okay, so that's 3 over 2. Agreed? Let's get the denominator as well. So denominator is y square dx. The limits are going to be 0 to 1. Remember, it's the x limits. So y is 3x square. So y square. Okay, because y is 3x square, you have to square it. Okay, and that's going to give you 9x to the power 4 dx. Limits are 0 to 1. Let's integrate. So 9x to the power 5 over 5, and your integration limits are from 0 to 1. So when you replace x with 1, okay, can you say 9 into 1 to the power 5 over 5 minus it is 0. So basically, this is 9 over 5, guys. Agreed? Right? So now let's substitute and get the x bar. So x bar equals numerator value was 3 over 2. Divide by denominator value is 9 over 5. Right, guys? So let's get the answer. So this will be 5 over 6. All right, guys. So it's going to be 5 over 6. Okay. Yeah. So center of mass coordinates x bar. Or you can say basically the center of mass coordinate x bar is 5 over 6, and you know clearly y bar is 0 because your center of mass is on the axis. Okay, so they're asking us to yeah, find the coordinates of the center of mass. Yeah, the question is to find the coordinates of the center of mass, so give the coordinates. All right, guys. So I think in the previous question, yeah, so we gave the center of mass coordinate. Okay. Okay, guys. So next I'll move on to question number 13. Okay, so they say here the diagram shows a frustum. Okay, so the diagram shows a frustum. So I think in the previous part, okay, so in the previous video, I was showing you how to get the center of mass of a frustum. Do you recall? So I think we did some work regarding that, this question. Right, so send how the example 12 I explained here, and we learned how to find the center of mass of a frustum. Okay, so we have to apply that theory here. And also in addition to that, I think that you can see, so this is the diagram shows a frustum of a right circular uniform cone. The frustum has end diameter 4 centimeter and 8 centimeter and height 8 centimeter. A cylindrical hole of diameter 2 centimeter is drilled through the frustum along its axis. So guys, can you see what's the difference now? So the difference between the previous sum and this is you have the frustum, and from the frustum they have removed a part inside the frustum. Can you see? So if you look at this, look very clearly, this removed part looks like what? It looks like a cylinder. It's a cylinder. So from the frustum, you remove the cylinder. And now your task is to find the center of mass of the resulting solid. Okay, from the larger phase of the frustum. Okay, so get the let's get the answers. So first thing is you need to, you need to get the center of mass. Like you have to write down the whole set of diagrams, right? So how do you first get the frustum? So from the work we did on the previous day. So first we get the frustum by taking, there's a larger cone, right? You create the frustum by taking the larger cone and removing a small cone. So that's how you get the frustum. Right, guys? So let's get into that. Okay, so we have a large cone. Okay, so you have a large cone. And from that, you remove, right? I'm using a minus sign here to identify that I should remove it, okay? The minus sign here tells me that I should remove, okay? So minus a smaller cone. Right, guys, can you see? From this larger cone, we remove a smaller cone. So the center O is over here. Okay, so remember center of mass distances should be measured. So I'm measuring it from the base. Let's say we are measuring, and our base here is O. Okay, so we are measuring everything from O. Okay, so this is the O. So have one point where you always measure the center of mass. So from the large cone, when you remove the small cone, guys, you get the frustum. But we are not done with this sum. So it's not the frustum that I want. We don't want, we are not supposed to get the center of mass of the frustum, but we're supposed to get the center of mass of the object after we even remove the cylinder also. So what's happening here? From the large cone, you remove the small cone, you get the frustum, and then from that frustum, you again what? you again remove, right? So again you remove a cylinder, right guys? So again you remove a cylinder. Are you guys with me? So you remove this cylinder. And this cylinder is having the base O, right guys? It's on the base O. The cylinder is right on the axis of symmetry and it directly, can you see? On O, the base. Okay, and then you close that, and then guys, you can see from the large cone, you remove the small cone. Okay, so large cone is what you have over here, the full shape. Can you see? The large cone is the blue one. So from the large cone, you remove the smaller cone is the one that you have on top, the green one. Okay, so the green color one is a small cone. And then you have the remaining part is the frustum. And then from the frustum, you remove the cylinder. And then guys, you can see now you are remaining with the shape that you require, right? So now we are remaining with the frustum. Agreed? So now we are remaining with the frustum. Okay, and then you have it. Okay, so let's complete the diagram now. Let's input the rest of the information. All right, guys. So now, in order to get the mass, mass is proportional to the volume, right? When it comes to 3D object, mass is proportional to the volume, and we say let the mass per unit volume be rho. So you introduce a variable like that, right? And then do you recall now to get the volume of the cone, the volume of a cone is 1 over 3 pi r squared h, right, guys? 1 over 3 pi r square h. So you need the radius and the height. So when it comes to the large cone, okay, so we can clearly see the diameter of the large cone is 8, which means radius is 4. That's fine. But we have an issue. We don't have the height. Can you guys see? We don't have the height of the large cone. So let me draw a cross section of the large cone. So if I draw a cross section triangle, guys, can you see? I'm just drawing a cross section triangle here. Can you see? I'm drawing a triangle inside. This triangle inside is what I drew. Okay, so the cross-sectional triangle is what I have drawn over here. Okay, slightly larger, but anyway, it's the same thing. But I'm trying to draw. And then let's mark all the information. What do we know here? We know that the this part, this is the O. So O to here, that's going to be 4 centimeters. And then guys, somewhere in the middle, not exactly middle, but we have the other guy over here, right? So let's say this point is point A. So this is point A, okay? Okay, and at point A, the distance is half of 4, right? So this is 2. You guys agree? Okay, and then we also know that this height is 8, right, guys? This is the part of the frustum. So this is 8. Okay, so I want to get the height. Now, when I use mass of the large cone as 1 over 3 pi r square h, you know that I require the full height of the cone. And you can clearly see I don't have the full height. So how do you find the full height? You can use similar triangles, or previously I also showed you can do it by tan alpha, right? So you can just mark the top of the angle of the cone as some theta or alpha, and just anything, okay, any angle. And for the two right angle triangles, the tan ratios are going to be the same, right, guys? Do you agree? So let's say this height is let's say this is some simple a. Okay, so let's use tan alpha for the large triangle and the small triangle. So when you use tan alpha for the large triangle, guys, large triangle opposite over adjacent. Opposite is 4, adjacent is 8 plus a, right? Do you agree? That's the large triangle. If you consider the small triangle, tan alpha opposite over adjacent, opposite is 2, adjacent is 8. Okay, guys, so 4 over 8 plus a equals 2 over a. Guys, cross multiply, get the value of a. 4 times a equals 2 times 8 plus a. So 4a equal 2 times 8 is 16. 2 times a is 2a. So 4a minus 2a is 2a equals 16. A equals 16 divided by 2. That's 8. Right, guys? Can you see? So a is 8. So which means the total height of the cone, the total height is going to become 8 plus 8, 16 centimeters. Right, guys? So I have the total height now. Okay, so we are ready to go now. Shall we input that value here? Okay, and remember rho is the mass per unit volume. Okay, rho is the mass per, or you can say mass per cubic centimeter, because over here we are working with centimeters. So that means you are going to get your volume in cubic centimeters. So mass per cubic centimeter. Okay, so every cubic centimeter weighs rho. Okay, so you can use that as your rho. And let's, so I need the mass. Okay, so if you want the mass, okay, so mass is going to be 1 over 3 pi. Radius is going to be for the large cone, that's 4 square. Height was 16. Let's simplify. What's the mass? 1 over 3 into 4 square into 16. So 4 square is 16 times 16, it's 256, right? So 256 over 3 pi. And don't forget the rho. Okay, so you have to multiply by your rho here, right? To get it mass, to make it mass. All right, guys. So that's the mass. And then when it comes to the center of mass, now when it comes to the center of mass of a cone, the equation is already now when it comes to a question like this, you are directly allowed to use the formula unless or otherwise they ask you to prove the equation of the cone as 3h over 4. So that also we've done, right? Okay, so here we've done this. Can you see? So center of mass of a solid, right? Yeah. So right circular cone is given here. So it's 3h over 4 measured from the vertex. 3h over 4 of a distance measured from the vertex. So unless or otherwise they ask you to do the proof, you don't need to do this proof. You can directly use the result. Okay, 3h over 4 result can directly be used unless they ask you to prove. So sometimes they might ask you to prove in a part A of the question, right? So they can give this as a part B, and in part A they might ask you to do the proof. Okay, so anyway, if they ask you the proof, you need to do that entire thing. If not, you can directly go with it. So it's the center of mass is 3h over 4 from the vertex, but I want the center of mass from the circular base. So if 3h over 4 from the vertex of the cone, the other distance, the center of mass should be h over 4, right, guys? Because the other side distance was 3h over 4. This distance should be h over 4. Great. So that's going to be h over 4. H is 16 divided by 4, which is 4 centimeters. Right, guys? Do you agree? Okay, guys. So we'll move on to the center of mass of the cone. So we'll move on to the smaller cone, right? The one with the green color one. So volume is 1 over 3 pi r squared h, which means mass is 1 over 3 pi r squared h into rho, the mass per unit volume or the density. Okay, so then let's input the value 1 over 3 pi. Radius of the smaller cone is, so diameter is 4, radius is 2, right? So 2 square. And height of the smaller cone, guys, the small cone has a height of 8 centimeter, right, guys? Can you see? Because the whole thing is 16, this is 8, so which means the smaller one has a height of 8 into rho. All right, guys. So what do you get here? That's 4 times 8, that's 32 over 3 pi rho. Great, that's 32 over 3 pi rho. And then let's give the center of mass. So once again, when it comes to center of mass, guys, you know the rule. The center of mass is at a distance 3h over 4 from the vertex. Okay, but if you consider it from its own base, okay, so let's say this is the G2. Okay, so this will be at a distance h over 4. Now remember, this h is the height here. The h here is the height of that particular cone. So height of the cone, now when it comes to the smaller cone, the height of that cone is 8 centimeters. So you take that h over 4, but remember h over 4 is the distance from the base of the cone. Okay, but remember we are giving the center of mass measured from O. I'm considering O as my 0, 0. Okay, so I want all the coordinates measured with respect to O. Now remember h over 4 is the small height over here. Okay, between the base of the cone to the center of mass of the cone. But I want this full height, and you guys can see this part of the height is the height of the frustum, right guys? So you have to add the 8 centimeters here. That's really important. So h is, in the case of the smaller cone, h is 8. So 8 over 4 plus 8, so 8 divided by 4 is 2, 2 plus 8 is 10. 10 centimeters. So this is the center of mass of the cone, the smaller one. And guys, as you can see when I'm finding the center of mass, I'm only interested in the y coordinates. As you can see, I didn't even explain about the x coordinates. So that's very obvious, right? Because the cone is having a line of symmetry. So clearly x by 0, right? Clearly x by 0, we don't even need to find it. I don't need to find it because I have considered O as my 0, 0, and you can see the entire cone is symmetric around the y-axis. If I consider this as my y-axis, the entire cone is symmetric around the y. So x bar is clearly 0. I don't need to find x bar again. So I'm only uh, working with the y coordinate. So, all right, guys. All right, guys. So moving on to the next one. So the cylinder that you are removing. Okay. So guys, this cylinder that you are removing, clearly you can see has a height of 8 centimeter and the radius. So a cylindrical hole of diameter 2 centimeters. So the diameter of the cylindrical hole is 2 centimeter, which means the radius of the cylinder is, guys, 1 centimeter, right? So mass is gonna be anyway, you need to remember the formula, right, guys? When it comes to the center of mass, when it comes to the center of mass lesson, you need to recall all the volume formulas, okay? So that you've learned in your O levels. So you need the mass of a cylinder, or in other words, you first need the volume of a cylinder. So what's the volume of a cylinder? The equation. So the equation is pi r square h, right, guys? You need to remember this. Volume of a cylinder is pi r squared and multiply by the density rho. Okay. So input the value pi, radius is 1, and height of the height of the cylinder is equal to the height of the frustum, right? So that's 8 into rho, and then you get here 8 pi rho. All right, guys. So that's 8 pi rho. And then the center of mass. So center of mass measured from O. I think you can see very clearly the cylinder. You don't need any special equation for the cylinder, right? Now for the cone, we had the equation 3h over 4 and h over 4. And even for hemispheres, we have all these equations. But when it comes to a cylinder, I think I told you at the very beginning that the cylinder is a symmetrical object, right? You have several planes of symmetry. So therefore, the center of mass of a cylinder is exactly in the middle of the cylinder. So exactly in the middle of the height. So if it is 8 centimeters, guys, you can see that the center of mass, the G3, is going to be exactly in the middle, right? So this is 8 centimeters. So the center of mass is going to be at 4 centimeters measured from O. And you don't need anything else to add over here because from O to G, the center of mass is directly 4. So directly 4. Center of mass is directly 4. Very clearly. Agreed, guys? So that's filled. And now the last part. So last part is the final mass. So how do you get the final mass? I'm sorry, for the final mass, you have to remove the cylinder also, right? Over here, the cylinder is gone. How do you get the final mass? So guys, in the final mass, you have the frustum where the cylinder is removed. So how do you get the mass? All right, guys. So the remaining mass, the mass of the rest of the frustum is, guys. So from the large cone, and you can see I even used the minus signs here to tell you about that you're supposed to remove the smaller cone and the cylinder. Okay, so that means the remaining mass is gonna be, if I take, so it's gonna be 256 over 3 pi rho. From that you subtract 32 over 3 pi rho minus 8 pi rho. All right, guys. So you have to subtract, and all of them have pyro at once. So you can directly give in the cal 256 over 3 minus 32 over 3 minus 8. And then we get the answer as 200 over 3 pyro. All right, guys. And the center of mass is what we are trying to find from O. That is y bar in this case because we are finding the vertical height. From O, we are trying to find the vertical height. We don't need the horizontal height. All right, guys. Okay, guys. So this table is the most important part. After you've done with this table, basically we are almost done with the sum, right? Because now all you have to do is to apply sigma mi, not xi. We are dealing with y coordinates. So sigma mi yi equals total mass into y bar. All right, guys. Our total mass is sigma mi. I just use capital M. Okay. So sigma mi yi means you multiply mass with the center of mass. First mass is 256 over 3 pi rho. Multiply with the center of mass, that's 4. Can you see, guys? I'm multiplying this pair, the mass and the center of mass. The next pair, even though we are supposed to add, you can see that's why I have used a negative sign here because we are removing it. So when you're removing it, make sure you give you give the minus mark in the middle, okay? Not an addition. Even though it's a summation, we are removing object. So it should be a negative sign. So minus mass is 32 over 3 pi rho. Its value multiplied by 10. So that's the center of mass. Next one, the cylinder. Again, that is something that we are removing. So remove minus mass is 8 pi rho into center of mass is 4. Can you see, guys? So you multiply the mass, take the product of the mass and the center of mass. So this is equal to the total mass is 200 over 3 pi rho. 200 over 3 pi rho into y bar. We are trying to find y bar. All right, guys? Okay, so now time to simplify this. Everyone has pyro. Remove pyro. Every single term here has that. So remove that and let's get the answer. 256 over 3 into 4 minus 32 over 3 into 10 minus 8 times 4 equals 200 over 3 into y bar. All right, guys. Okay, so now let's time to try, to just type everything in the cal and let's get the answer. Alright, guys, so I get here on this side 608 over 3 equal to 200 over 3 y bar, and then you simplify, 3 cancels out, 608 over 200, and then you simplify, and you get 76 over 25, or in other words, the exact answer 3.04 centimeters, because all the measurements are done here in centimeters. So this is the distance to the center of mass from the base of the larger face of the frustum. So they're asking us to find find the distance of the center of mass of the resulting solid from the larger face of the frustum. Okay, guys, so we have found that. All right, agreed. Okay, so this is one full question. So I hope you guys can understand how to work with these types of these types of center of mass questions now. Okay, guys, so let's move on to question number 15. It's slightly different from the previous ones. Okay, but they say here a thin, uniform, hollow cone. Can you see now the difference is you don't have a solid cone. So you are working with a empty one. It's hollow. Okay, has a circular base of the same material. Okay, so there is a circular base made of the same material. Find the position of the center of mass above the base given that the radius of the cone is 3 centimeter and its height is 4 centimeters. So actually, it's a very small question, but still there's a little bit to think here. How do you get the center of mass? Now, there are several issues here. Number one, that you're working with a hollow cone. And also this hollow cone, they say there is a circular base, which means the inside is empty, but there is a circular base here. Do you guys get what I'm saying here? This is not empty. So basically, you take a hollow cone and you fit a circular base. So when you look at it, it looks like it's complete, but inside is completely empty. Okay, a thin uniform hollow cone has a circular base of the same material. So of the same, this is what it says, of the same material. So which means whatever the material that the cone is made of, there is a circular base made with the same material. Can you understand? So which means this cone is not open. Okay. Even though the inside is empty, you have fitted. It's like there's a lid. At the bottom, there's a lid, a circular lid. Okay. Now, how do we get the center of mass? How do we get the center of mass? So there are several things here. Again, you can make your table the object, mass, and the center of mass, but you have to be really cautious here. Why? Okay, so I'm getting the center of mass from the point O. So point O is the bottom. So the first object, guys, let's take the hollow cone. Okay, so what you do here is let's take the cone as the first object. Okay, so this is the hollow cone, the first one. I'm considering the hollow cone. Okay, how do we get the mass of a hollow cone? Now, previously when we were working with solids, I told you that we should use the volume, right? So when it's a complete solid, we use the volume as proportional to the mass. But now when it comes to a hollow object, is it okay? Do you think that it is correct to use the volume as to show the proportionality to the mass? Okay, guys. So over here, the best thing to go, even the hint, they have even provided you the hint. So the curved surface area of a cone of slant height L and base radius R has area pi RL. So actually, they are asking you to what? To go with area. So we'll go with curved surface area. All right, guys. So we'll go with the curved surface area. And if you want, you can even consider the thickness. So there's a slight thickness here, right? Because of the way they were drawing. So you can even multiply and get the thickness also. That's also okay, but it will cancel out. Okay, so let's say let rho. Okay, so this time the density. So let the density of the material be rho. Okay, so remember now this time rho is proportional to the mass. Okay, so rho be the mass per unit area. Okay, rho is the mass per unit area. And you can even consider the thickness if you want, or else even if you don't take it, that's okay because it will cancel out. So thickness, let's say this value is T, you can use any value as you want, okay? And then you can clearly see the center of mass is on the axis of symmetry. So we don't have any, you don't need to find X bar. X bar is clearly 0 because you are on the line of symmetry, okay? So X bar is 0, we only need to find Y bar. Okay, so we'll go with, remember whenever you're working with hollow objects, I think the best here thing to remember here is when you're working with hollow objects, go with the area. Okay, and if you're working with solid objects, go with the volume. Okay, so and then yeah, so then first we'll get the mass of the hollow cone, and then we have the rest of the object. Okay, what are the rest of the things here? So is it only the cone we have? No, right? They say they are fitting the cone has a circular base of the same material. So there's a material that's a circular base of the same material. Okay, guys. So there's a circular base that is fitted to the cone. Okay, so that is the important thing here. You have to identify that there is a circular base fitted to the cone. All right, guys, and then all together you have the complete object. All right, guys, can you see? All right, guys, can you see how it's done? Okay, so this is the cone. Okay, so you can see that you have the hollow cone. So this one is empty. Then you fit the circular lid, and then you get this. Okay, right. So let's go for the mass. So mass is proportional to the area. So we can go for mass as pi RL. Okay, so let's get the values. But the slant height here, L stands for the slant height. So you'll have to get the slant height. What is that? Okay, so you can get the slant height by using Pythagoras theorem, right? Height of the cone is 4, radius is 3. So you can use Pythagoras theorem, L square equals 4 square plus 3 square. Agreed, guys? L square equals 4 square plus 3 square. So L is equal to square root of 25, which is 5. Okay, so we have L as 5 centimeters. All right, so now time to get the mass. So you can consider mass is pi RL, right, guys? So pi into radius is 3, slant height is 5. And guys, you can multiply by the rho and also by thickness. Now remember thickness is, if you multiply by thickness, then you have to consider all these objects as having uniform thickness. Okay, if you are considering a thickness, then not only the cone but the base, the base that you are attaching also should have the same thickness. Okay, or else you can completely remove it, because anyway this pi, the rho and the t is going to be common to everyone, and in the main equation it's all going to cancel out. Okay, just because I think if I don't use it, you guys might be confused, because you can see this shape has a certain thickness to it, right? Okay, so basically you get here 15 pi rho t. Agreed, guys? So I get here 15 pi rho t. And the center of mass, guys, so center of mass of a hollow cone. Now, previously we did a center of mass of a solid cone, that was 3h over 4 from the vertex, or h over 4 from the circular base. But separately, we have also done the center of mass of a hollow cone. So that's a theory that we've done previously. So what was the answer? Center of mass of a hollow cone. Yeah, guys, I think it's over here, right? Center of mass of a conical shell. This one, right? The center of mass of a conical shell lies on the axis of symmetry and is at distance 1 over 3h from the base. So 1 over 3h from the base, right guys? Can you see this diagram? So I think I've explained this previously, right? So it's the center of mass of a conical shell is 1 over 3h from the base, or 2/3 h from the vertex. All right. So make sure you go for the correct equation, and you need to remember these equations. All right, in order to use them. So 1 over 3h from the base. 1 over 3h from the base. I'm considering from the base, right? Not from the vertex. So 1 over 3 into h is height is 4. So that's going to be 4 over 3. All right, guys. All right, guys. So then moving on to the next one, the circular lid. Okay, so this is the circular lid that we are fitting to the cone. Okay, so the circular lid that we are fitting to the cone. So what's the area? Once again, remember mass is proportional to the area. The area is going to be pi r square, right? Area of the circle. So it's pi r square, guys. And then also remember, we need to multiply by rho, the mass, and thickness. As I told you, the thickness is going to be uniform for all the objects. Okay, so even for the circular base. Okay, so input the value, radius is 3. So pi into 3 square into rho t, that's going to be 9 pi rho t. Right, guys? And then you can see that your circular base is directly on the y-axis, right, guys? It's directly on the y-axis. So what's the center of mass? Guys, the center of mass, since you are measuring the y distance from O, remember you are measuring the y distance from the point O. So but the circle is directly on top of O, right? So is there any distance? Is there a height that you need to go for to take the center of mass of the cone of the particular of this circular lip? No, right? I think you can clearly see that the center of mass, the height from O to the middle of the circle is directly 0, because the center of mass of the circle is directly on top of O. So that's 0. Right, guys? Can you see it? Okay. So finally, let's get the final mass. You have to add these two, guys, right? Because over here, it's addition. Okay. Now, in this case, it's addition, not a subtraction. Previously, I used to put minus mark here to remind myself I should subtract. But now we are adding the circular base to the hollow cone, and we are fitting it to make a single object. So over here, 15 pi plus 9 pi, that's going to be 24, right? You're adding everything together. 24 pi rho t, that's the total mass. And center of mass, y bar, is what we are trying to find. So guys, this is it. As long as you are able to create this table properly, you should be able to get your answer. It's the creation of this table that takes a longer time. Okay. So now let's multiply sigma mi yi equal total mass into y bar. So multiply sigma mi, so mass is 15 pi rho t into 4 over 3, plus it's an addition this time, right guys? It's a addition, not a subtraction. So 9 pi rho t into 0. this time. It's a 0. You're multiplying with y coordinate 0. Equal total mass 24 pi rho t into y bar. All right, guys. So when you multiply, everyone has pi rho and t. So you can remove pi rho and t. And you can get here 15 into 4 over 3 plus 9 times 0 is 0. This is 24 y bar. So guys, get the answer. 3 times 1, 3 times 5. So 5 times 4, that's 20 equals 24 y bar, right guys? So y bar is 20 over 24, right? So 4 times 5, 4 times 6. So y bar is 5 over 6 centimeters. So the center of mass is at a distance of 5 over 6 centimeters above the base. All right, guys. All right, guys. So we'll move on to question number 17. So this is a good one to practice for the exam. So look how it's done. The finite region R shown shaded on the diagram is bounded by the curve with the equation y equal 8 minus x cube and the coordinate axis. Can you see? So you have y equal 8 minus x cube and the coordinate axis. The region is rotated through 2 pi radian about the y-axis. Guys, be very cautious here. Now they are saying it's not a rotation around the x-axis, but it's a rotation around the y-axis. So basically, you are rotating around the y-axis to form a uniform solid of revolution s. Find using algebraic integration the y coordinate of the center of mass of x. So this is actually really easy as long as you remember the theory. So basically, if you are revolving around the y-axis, guys, what's the rule? So now don't reflect on the x-axis because our revolution is now happening around the y-axis. So which means the reflection. So you don't need this part, right? I think you can see that we don't need this section. I can remove it. Okay. So we are only taking the finite region, only this part. So reflect it around the y-axis. Reflect it around the y-axis. Guys, can you see? Okay, so this is the graph when you reflect it around the y-axis. And then what do? They say the region is rotated through 2 pi. So you reflect it and any open end becomes a circle, right? The open end becomes a circular face. So this is the open end here. Can you guys see? So this is forming a circular face. This is a closed end, but over here this is closed. This is open. This becomes a circular face. Guys, can you see? So you get something like almost like a bell shape. Okay. Okay. The question here is what? Find using algebraic integration the y coordinate of the center of mass. Clearly, you have the y-axis as a line of symmetry. So you need to get the. They are asking you to find the center of mass of the y coordinate. Right, guys? Okay, so let's get it. Let's remind ourselves of the theory. All right, guys. So this is the theory, right? So you had used the very first theory that we learned regarding 3D objects. So if you are revolving, the first one is for a revolution about the x-axis. So that's not what I want. I want the revolution about the y-axis, right, guys? So this is the first time we are using this equation. Are you with me? Okay, so let's get it done. So what's the equation here? For part A, y bar equals integration of x square y. Integration of x square y dy divide by integration of x square dy. Alright, guys. Okay, so where m is the known mass of the solid, okay, and rho is the density. Okay, so this is the equation, right? X square y dy over integration of x square dy. Remember now the integration happens with respect to y. The integration now happens with respect to y. Therefore, you need to perform, you have to convert the entire equation in terms of y, not in terms of x. Why? The integration happens with respect to y. And also, what does that mean? It means your limits should be now y limits. Okay, so you should give the y limits here. Are you with me, guys? Okay, so let's get the y limits. So what are the y limits? Obviously, I can see the starting, the lower limit is a 0. Very clearly, we can see lower limit is a 0. And the upper limit, guys, the place where you cut the y-axis, right? So when you cut the y-axis, x is 0. So when you set x to 0, I think clearly you can see you cut the y-axis at the top point. That's 8. So your integration limits are from 0 to 8. Do you agree? Your integration limits are from 0 to 8. All right, guys. Okay, and then okay. So now let's get. I'll get the numerator separately. So numerator is integration 0 to 8 x square y dy. So guys, if you want to now remember, we are trying to solve the with respect to y. Okay, I need to get rid of the x square, not the y. Now don't replace y as 8 minus x cube. Are you with me? So if you replace y as 8 minus x cube, that's not what you're supposed to do. You have to replace the x value here. So what is x, guys? So you can write x cube is 8 minus y, which means x is 8 minus y to the power 1 over 3. Are you with me, guys? It's 8 minus y to the power 1 over 3. So which means x square is going to be 8 minus y. You are taking the power 2 to both the sides. So if you're taking power 2 to both the sides, it's going to be 8 minus y to the power 2 over 3. Right, guys? Because I'm squaring both the sides. Can you guys see what I'm talking about? I'm squaring both the sides. So x is the cube root of this. Then you square both the sides to get x square. Substitute the value here. 0 to 8. Instead of x square, you have 8 minus y to the power 2 over 3 times y dy. Alright, guys. Okay. So now we have everything in terms of y, and now we need to integrate. Okay. So now think about the rules. How are you going to integrate this? So guys, now to perform the integration here, the challenge here is the integration. So you can't use the reverse chain rule. Basically, for the reverse chain rule, you need to see that this powers this is P4 integration, right? So we are trying to try a P4 integration technique. So if you try this, the you need to have the perfect differentiation of the in function. So inside here, the power you have 8 minus y, and outside you have the differentiation of 8 minus y is minus 1, but you have a y here, so that this rule does not apply. This is a P4 rule I'm talking about. Sorry, a P3 rule, right, guys? This is from P3. Reverse chain rule is from P3. Okay, so that P3 technique is not going to work. So we'll move on to a P4 technique. So in P4, one of the best ways to do this is, guys, now you need to, of course, you need practice to remember these kinds of things. Okay, so the best technique that works here is actually integration by substitution. Okay, not integration by parts. Even that's going to be a little bit of a trouble. So even that works. Integration by parts also should work. But the easiest, I believe, is maybe using integration by substitution. So let's go with that. So the thing is, you need to replace the person that is the most difficult. Now here you can see we are having trouble with this section. 8 minus y to the power 2 over 3 is what we have trouble with here. So let's say let, okay, so I'm going to input the variable u. Okay, so I'm going to say let u be equal to 8 minus y. Okay, so u is 8 minus y. All right, guys. And then, when you are going to do a substitution, you have to replace. You have to replace all the y's are going to be replaced by u. And even the y limits should be replaced by u limit. And dy also should be replaced by u. So everything has to convert to u. Shall we do that? So let's differentiate. First thing, when they give you a substitution, I have told you differentiate. So du by dy equals 8 differentiation is 0, minus y differentiation is minus 1. You are differentiating with respect to y. So you get here du equals minus dy, or in other words, dy is minus du. You get something like this. And also you can replace the limits. So your y limits, right, guys? When y is 8, what's the u limit? So u is 8 minus y, right, guys? 8 minus y is 8. So which means when y is 8, u is 0. Right, guys? The other one, when y is 0, u is 8 minus y. So u is 8 minus 0, which means u is 8. Can you see, guys? So I'm replacing the limit. So when y equal 8 limit is replaced by u equals 0, y equals 0 limit is replaced by u equal 8. So let's substitute that over here. 0, so when y is 0, that becomes u limit is 8, and y limit 8 is replaced by 0. Guys, can you see? The limits are replaced. And you get here 8 minus y. 8 minus y is u. Okay, 8 minus y is u, and you have u to the power 2 over 3, right, guys? Because it's 8 minus y is a u, and there's a power 2 over 3. Into there's y again, guys, with y. If u is 8 minus y is 8 minus u, right, guys? So inside brackets, replace y with 8 minus u, because I had to get rid of all the y's and get the equation completely with u. And next dy is replaced by minus du. So into minus du. All right, guys. So let's take that minus sign out. Minus integration from 8 to 0. You have u to the power 2 over 3. 8 minus u du. All right, guys. The minus sign, I brought it forward. Agreed? Okay, so I think you can see now we can integrate, but not yet. We have to first. I think you can see you can't integrate when there's a product. Let's expand. Let's expand this bracket. It's really easy to expand the bracket, right? U to the power 2 over 3 into 8 is 8 u to the power 2 over 3 minus u to the power 2 over 3 into u to the power 1. That's going to give you how much? The powers will add, right? 2 over 3 plus 1. So that's 5 over 3, right, guys? I still did not integrate. I was just expanding the bracket. I have not yet performed the integration. Okay, guys. So now shall we perform the integration then? It's ready to perform the integration. So this is going to be 8 u to the power 2 over 3 plus 1. So 2 over 3 plus 1 will be 5 over 3 divided by 5 over 3, right, guys? And then this one u to the power 5 over 3 plus 1. That's 8 over 3 divided by 8 over 3. Am I correct? Let's check on my version. Okay, guys, so I've done the rest of the work here. You can see I've substituted first the u with 0, then minus in the middle, and then replace the u with 8. And you can type the whole thing in the cal, you get 288 over 5. Okay, and also some of you were telling me, like, you can get it off the minus over here immediately if you want. Like how? If you exchange the limit 0 to 8 and write this as 8 0 as 0 and 8, the negative sign will be used up. Okay, so if you exchange the limits, the negative becomes a positive, and then you can do this sum in this manner. All right, guys, 8 u to the power 2 over 3 minus u to the power 5 over 3, and you can go for the integration. Okay, that is also correct. Okay, that was a suggestion. That is correct. If you exchange the limits, the minus mark you will generate another minus mark. In other words, then it becomes a plus mark. That's also correct. So you can go with that. So 288 over 5 is the answer for the numerator. Now let's get the denominator. The denominator will be integration of x square. Let me get the denominator over here. Denominator is going to be integration of x square with respect to y. Limits are from 0 to 8. So x square is, guys, what's x square? X square is 8 minus y to the power 2 over 3 dy. 0 to 8. Okay. So guys, for this one, if you want, you can even perform you can do the substitution. Or else actually for this, you can even do direct integration, right, guys? Okay, so for this one, you can do direct integration. How? Because it's the first rule of integration, ax plus b to the power n. So you can directly add 1 to the power, right, guys? We can apply the very first rule of integration. 8 minus y to the power 2 over 3 plus 1 is 5 over 3 divided by 5 over 3. And since here it's a minus y, the a value is a minus 1. You remember integration of ax plus b to the power n, the very first rule is 1 over ax plus b to the power n plus 1 divided by n plus 1 plus b. So this is the rule. Okay, here the y coefficient is minus 1. So you have to divide by that y coefficient. All right, guys, and then input the limit. So your limits are from 0 to 8. Input the limits and get the answer. If you want, you can go for the substitution here as well, because we already have everything fixed here. You can replace the entire sum with u and also do it. That's also correct. So minus, it's going to be 3 over 5. So first one, 8 minus 8 is a 0. Minus the next one is again 3 over 5 times, replacing y with 0. That's going to be 8 minus 0 to the power 5 over 3. So how much is that, guys? 8 is 2 to the power 3. So that's going to be, yeah. So how much is it? 2 to the power 5, that's 32, right? Get the answer. Right, guys? So this is going to be 96 over 5, right? Okay, so we have the answer for the numerator and the denominator. So now time to substitute that here. So that's going to be 288 over 5 divided by 96 over 5, right, guys? And then we get the y bar answer as 3. Great. So we get the y bar answer here as 3. Okay, so that's the answer for part A, 8 marks. All right, guys. Okay, guys. So now we've done part A. Moving on to part B. They say a solid chocolate egg is formed by attaching a uniform solid hemisphere to the base of the solid S as shown in the diagram. The units of measurements are centimeters. Okay, so they are saying a solid chocolate egg is formed by attaching a uniform solid hemisphere to the base of the solid S. So guys, solid S is what we have over here, right? Uniform solid of revolution is what S is what we had over here in part A. Now they are saying they are attaching a hemisphere to this one, what we had in part A. They are attaching a hemisphere to that particular object and they are asking you find the distance of the center of mass of the chocolate egg from its base X, giving you answer correct to 3 steps. So that's 5 marks. So guys, this is what we've been doing earlier. You make the table, right? Object, mass, center of mass. And how many objects are there? So one object is this bell shape, which we know the center of mass, and also we can get the mass also, right? And then we have the hemisphere, and then you have the full object, right, guys? This is really easy. Part B. How do we get the volume of it though? In part, because in over here, guys, when you're making the table for object mass, center of mass, you need the mass of this particular object, right? So how do you get the mass or the volume? Volume of a solid of hemisphere, guys, a solid of revolution. So you've done that in P4, right? Part B, volume of an object that you do solid of revolution is found by pi y square dx if you are doing it with respect to the x-axis, or if you are doing with respect to the y-axis, volume equal pi x square dy. Do you remember? This is the equation you've done in P4. This is the volume equation. Volume is pi y square dx, volume of revolution around the x-axis. So if it's volume of revolution around the y-axis, it's going to be pi x square dy. And if you check on it, guys, pi x square dy, I have found it. Can you see? In part A, pi x square dy is my denominator. Right? So pi x square dy, the pi is not there, but the integration of x square dy answer is, guys, 96 over 5. Do you see? The integration of x square dy answer is 96 over 5. So volume is pi times 96 over 5. Can you see, guys? So it's 96 pi by 5. That is very important and that's a shortcut. So we need, because the thing is when you're making the table, we need the mass. And since this is a solid object, the mass is proportional to the volume. So you need the volume of this particular bell shape. Now this is not a standard shape, right? You understand that the shape, this particular chocolate egg is made by combining a standard hemisphere, but the top part is made from what you got in part A, and that's not a standard shape that you have the equation. You can't use the volume of a cone or volume of a cylinder for this, right? So when it comes to an object like this, to get the volume, you have to use this equation for the volume of revolution. So volume of revolution around the x is pi y square dx, but if it's around the y axis, it's going to be pi x square dy. And how did I get the value of x square dy? Guys, I have found it. If you check in this particular y by equation, x square dy is part of my denominator. So I'm going to the denominator. I have done the denominator separately. So denominator answer for integration of x square dy was 96 over 5. Okay, so that's my volume then. So 96 over pi is the answer for this, multiplied by the constant pi. So I have my volume. Okay, so we are all done now. Let's make the table. Object, mass, center of mass. Okay, guys. So object, mass, center of mass. Let's make the table. Okay, guys. So first object is the top part of the egg. So let's consider the first part as the top part of the egg. Okay, so let rho be the mass per or the density. Okay, so rho is the density or mass per unit volume. Okay, so then we can get the mass 96 over 5 pi times rho. That's it. Just multiply by the rho. Volume, when you multiply with rho, you immediately get the mass. All right, guys. And guys, now the thing is when it comes to the center of mass, they are asking you to find the center of mass from the base of the chocolate egg, right? From the base X. Can you guys see? Now, if you check the full diagram, look at where I'm pointing. Can you see base X is below the below this particular part? So I think you need to realize here that this base X is not at the edge, the place where the top part of the thing is ending. It's actually over here, right? Can you see base X is somewhere over here? So basically you have a distance of the radius of the hemisphere. Do we know the radius of the hemisphere? What is the radius of the hemisphere, guys? So what is the radius of the hemisphere? So if you check on this, guys, you can see the radius of the hemisphere is equivalent. You can see that you are attaching the hemisphere to this, right? So radius of the hemisphere is equal to this distance you have over here, right? You need this distance. Can you guys see this? So this is the radius. I need this distance. Right, guys, are you with me? I need this distance and this is my radius. So how do I get that radius? So you can take the curve and when you cut you can get it from the curve, right? Y equal 8 minus x cube. So y equal 8 minus x cube and you can make y 0 because that's the place where you cut the x-axis. When y is 0, you get x cube is 8, guys. Then x is cube root of 8 is 2, which means the radius is 2. So many things to figure out here, guys. The radius is 2. Okay. So that's very important because the thing here is why do I need the radius? Because we need this distance, right, guys? So this is the radius. The radius is 2 centimeters. The thing is I need to get the center of mass, and the thing is the center of mass. Now I need to measure it from x. Now, if you recall the center of mass that you found in part A, what was the answer you found? The center of mass y bar answer was 3, and that is measured from the circular surface over here. So from here, the center of mass was 3. So this was the y bar you found, right, guys? So the y bar 3, let me draw it over here. The y bar equals 3 is what you get for this distance. This was the y bar you got as 3 measured from the circular surface at the bottom of this particular object. So the thing is, I am supposed to get the center of mass distance not from there but from the point x. So I have to get the total distance is gonna be that 3 plus that r. Right, guys? 3 plus the r. So 3 plus radius was 2, right? So altogether distance is 5. And that's really important. All right, guys? So these are the things you need to understand when you're doing this particular sum. Then the next object you're attaching is the hemisphere. You're attaching the hemisphere. The bottom of the hemisphere has this point x. Right, guys? So it's a solid hemisphere, isn't it? Yeah, they are saying they're attaching a solid hemisphere. A solid chocolate egg is formed by attaching a solid uniform hemisphere. So mass of a solid hemisphere. So mass is, you take it as proportional to the volume. So hemisphere is half of, you have to remember the formula for volume, half of 4 over 3 pi r cube, right? Half of 4 over 3 pi r cube. And don't forget to multiply by rho, the density. So mass is going to be equal to half of 4 over 3 pi. Radius is 2, right, guys? 2 cube into rho. So simplify, that's going to be that's 16 over 3 pi rho. Agreed, guys? Okay, guys, next the center of mass of the hemisphere. So I just turn back the page. So it's at a distance 3r over 8 from the circular face, right? From the circular face. I believe in our question, x is at the base. So we need the other distance. So this other part of the distance is going to be what? 3. You have to subtract from r, 3r over 8. That's going to be 5r over 8. Right, guys? From the base, so we have to go back to our sum. So in our case, the center of mass, okay, you are measuring from x. So it's going to be 5r over 8. Remember, 3r over 8 is from the circular surface. But from the other end, it should be 5r over 8. Agreed, guys? Okay, and we don't need to add anyone here because it's directly measured from it. So 5 into radius is 2 over 8. That's going to be 2 times 1, 2 times 4. That's 5 over 4. Right, guys? Final thing is the final chocolate egg. So you have this as your final object. Right, guys? So final object, what do? You're adding these two guys, right? So it's an addition. So you have to add the two volumes. Yeah, add the two masses. 96 over 5 pyro plus 16 over 3 pyro. So add them together. Uh, what is the mass? 96 over 5 plus 16 over 3. That's going to be 368 over 50. And the distance is y bar. I'm measuring from x, the distance to center of mass, wherever the center of mass, that is y bar. All right, guys. The table is made. Now it's time to simplify. All right, guys. So let's multiply. Sigma MIYI equal total mass into y bar. So total, so 96 over 5 times pi rho into 5 plus 16 over 3 pi rho into 5 over 4, right? Equals total mass is 368 over 15 pi rho into y bar. Right, guys? So pi rho is common to everyone. Remove that. So you are remaining with 96 over 5 into 5, 16 over 3 into 5 over 4, 368 over 15 into y bar. So what do we get here? 96 over 5 plus 16 over 3 into 5 over 4. That's 77 over 3. Then divide and multiply 77 over 3. You should divide by 368 by 15. That gives us sorry guys, it should be 308 over 3, right? Yeah. So that was error. 308 over 3. For this part, 308 over 3 equals 368 over 15. So then you divide 308 over 3, divide by 368 over 15. And we get the answer 385 over 92. Equals to y bar. Right, guys? So in decimal form, 4.18. Correct the previous step. Okay, so you can leave it like this or give the answer. Most of the time they would ask you to give the answer in exact form. Okay, so center of mass is at a distance of 4.18 centimeters from the base X. All right, guys? It's measured in centimeters. Yeah, the units of measurement are centimeters, right? They have given in the question. The units of measurement are centimeters. Right, guys? Can you see how it's done? So this is the full center of mass question, and now you can see how questions come up in the exam, right? So you use integration, find the center of mass, and use that in another part to actually get the form a complete solid. And then you find the center of mass of that complete solid. So I hope all of you understood all these questions that I've done so far. Okay.